All right, let's now go through this question here. So now we're going to talk about crashing with cost. So in most projects, shortening the completion time will involve an additional cost. So I want you to imagine for a second, imagine, you're on a work site and you got a whole bunch of people working here, and let's just say you know that it's going to take 5 hours for the carpenters to complete a certain activity. But now, if you spend a bit of money, you can get more carpenters, and now instead of it taking 5 hours, now it takes 2 hours to complete. So that's the idea of crashing with costs, the idea that you can expend more money to make things more quickly. All right, we can solve problems involving crashing with cost either by inspection or using a table method. And we've already seen inspection quite a bit, and now we're going to start seeing this new method, the table method as well. But let's just jump straight into example 1 here. So it says to restore a vintage train, 13 activities need to be completed. The activity network below shows the 13 activities and their completion time in hours. So let's see if we can do a forward and backward scan here. So we're starting at time 0, and then we're going to scan forwards. So I'm going to go 5, 5, 7. 7 is my bigger number. 5 plus 6 is 11. 11 plus 3 is 14. It's going to become 7 plus 2 is 9. 9 plus 4 is 13. 14 is my bigger number. 7 plus 4 is 11. 11 plus 2 is 13. This will be 9 plus 3 is 12. 13 is my bigger number. 13 plus 6 is going to be 19. This will become 14 plus 7, which will be 21. And this will become, this is correct, this will be 7 plus 2 is 9. 9 plus 3 is going to be 12. That means 21 is my bigger number. So that means it will take 21 hours to complete. 21. Then we can do our backward scan here. So my backward scan will be 21 minus 7. So 21 minus 7 will be 14. 21 minus 3 will be 18. 21 minus 6 will be 15. 15 minus 3 will be 12. 14 minus 4 will be 10. 14 minus 3 will be 11. 11 minus 6 will be 5. My smallest number here is 10. 10 minus 2 will be 8. 8 minus 2 will be 5. Sorry, will be 6. 5 is my smaller number. 5 minus 5 will be 0. Over here, now, see, we jumped the gun there. We should have waited until we got this one here first. So let's just pray to the mathematical gods that we don't mess this up. 15 minus 2 will be 14. 13. 13 minus 4 will be 9. Phew. 8 is the smaller number there, so we are safe because that's going to be 9 there. 13 minus 4 will be 9. That means 8 minus 5 will be 3 here. All right, now we can identify our critical path. It's going to be 0, 0, 5, 5, 11, 11, 14, 14, 21, 21. Determine the earliest start time of activity F. All right, where's activity F? Activity F is going to be, here it is. So the early start time activity F will be 7 hours. 7 hours. Next, the minimum time in which all 13 activities to be completed is 21 hours. Hey, that's what we found. Hooray. What is the latest start time for activity L? Where is L? L is here. So you can see it is going to be 18. That's what we found there. So it's going to be 18 hours. 18 hours. What is the float time of activity J? Where is activity J? Where is it? Can you see it? There it is. Activity J. It will be 13 minus 11. So remember, the way that you do this, the way that you find the float is you go, I'll do it in the correct colors here. You're going to go your LST, and then you're going to subtract that from your EST. EST. So this would be 11. This will be 13. 13 minus 11 will be 2. Perfect. So those are those questions right there.